Hello. The following example is example 4.1.4 from your notes. This is dealing with inverse functions. The definition of inverse functions are that f composed of g of x is equal to x and g composed of f of x is equal to x. Notice that both of these have to be true. Now, this says that f of x and g of x are inverses of each other. This is what we have to show in order to show that f of x and g of x are inverses of each other. So here f of x equals x cubed minus 1 and g of x equals the cube root of x plus 1. So I have to show that f and g are inverses. To do that, I'm going to start out with f composed of g of x. F composed of g of x means f of g of x. And again, work from the inside out. So working from the inside out, that means that g of x, in this case, is the cube root of x plus 1. So that means f of the cube root of x plus 1. There's nothing I can do here. So in the f function, replace all the x's with what we say they are here, the cube root of x plus 1. So that gives me the cube root of x plus 1 cubed minus 1. Notice there's nothing to do inside this parentheses, so I'm going to work with this exponent. With this exponent, I have an exponent here, but I have a cube root here, and the cube root cubed, they cancel each other. So what happens is I'm left with x plus 1 minus 1. And if you notice, 1 minus 1 is 0, and I'm left with x. That checks out. Then I need to look at g composed of f of x. I've shown f composed of g of x, now I have to show that g composed of f of x is also equal to x. Again, this means g of f of x. I'll work from the inside out, so the first thing I look for is f of x, and in this case that's x cubed minus 1. So that's g of x cubed minus 1. And again, go back to the g function and replace the x with what we say it is. In this case, it's x cubed minus 1. So what I'm left with is the cube root of x cubed minus 1 plus 1. So notice that inside this radical I have negative 1 plus 1, and negative 1 plus 1 is 0, so all I'm left with inside the radical is x cubed. Notice because this is an odd degree, I can do this. If it was not an odd degree, I would have to use an absolute value. Because it is odd, the cube root and the cube cancel each other, and you're left simply with x. So g composed of f of x is equal to x, and that checks out as well. Therefore, yes, f of x and g of x are inverses of each other.